So today what we're going to talk about doing is we are going to talk about how to multiply radical expressions. So this is going to involve things that we did last week where we were multiplying just radicals, and what we did yesterday, adding and subtracting radicals. So this also brings in stuff that we did back in chapter 8. So chapter 8, we talked about the distributive property, we talked about the FOIL method, and we talked about the box method. Here's what we're going to do today. We're going to do all of that stuff with radicals. Yay. No? Okay. Anyway. So we're going to combine all of that stuff together along with all of these awesome radical rules we know. So remember, you multiply the numbers on the outside, keep them on the outside. That still is true for today. Multiply numbers on the inside, keep them on the inside. That also works for today. And then lastly, you always want to make sure to simplify and make sure it's in simplest form. So this first one here, if I have the square root of 3 times the quantity 3 plus 6. Looking at this, this is a distributive property problem. You're going to do this the exact same way as if this was a number being distributed into like a polynomial expression. You are going to multiply the square root of 3 times 3. Here's the thing. That 3 is under the radical. That 3 is outside the radical. You can't multiply these together and make it into a 9. That 3 would have to stay on the outside, and that 3 has to stay on the inside, just like we did last week. Now, when I go and distribute the square root of 3 to the square root of 6, this time the 3 and the 6 are both under the radical. And if they're both under the radical, you can multiply them together, but you have to keep them under the radical. So it's the square root of 18. Now remember from yesterday, this is where it comes in from what we did yesterday. It would be nice if I could add these together, but remember from yesterday, since this is the square root of 3, and this is the square root of 18, I can't add them together. But also remember from yesterday, maybe I can, because that is not in simplest form. So we would need to take the 18, divide out of 2, we'd get 9, divide out of 3, we'd get 3, another 3, we'd get our 1. So I do have a pair of 3's. So first of all, that 3 square roots of 3 is going to stay the same. But that square root of 18 is going to turn into a 3 on the outside, left with a square root of 2 on the inside. Now when I simplify these together, they're still not like radicals, because it's a square root of 3 and it's a square root of 2. So you do need to simplify it because it's in simplest form, but you could not combine these together. You would just need to leave them separate. So that's how you would use the distributive property with these. Okay. Now the other thing we're going to be doing is multiplying using either the FOIL method or the box method. Now, I'll be honest with you guys, I definitely prefer the box method for these ones. Let's remind ourselves how these work. So if I want to multiply 5 plus the square root of 7 times 5 minus the square root of 7, guys, this is the same thing as whenever I did like x plus 3 times x minus 5. You could do the FOIL method, multiply the first, outer, inner, last. Or, since it's radicals and we're still kind of getting used to multiplying with radicals, I would recommend using the box method. Since I'm multiplying 2 terms, my box needs to be 2 by 2. I'm going to write a 5 plus the square root of 7 on the top, and a 5 minus the square root of 7 down the side. Make sure you include the sides. And then if you remember from the box method, to fill in the box, you are going to multiply. So to fill in this box, we are going to take 5 times 5. Which is 25. Now for this box, you are going to multiply the square root of 7 times 5. Same rules. The 5 is outside, the 7 is inside. You can't multiply these together and turn it to 35 because they're in different places. The 5 has to stay outside, the 7 has to stay inside. Same thing here. The 5 is outside, the negative square root of 7, the 7's on the inside, so you can't multiply them together, but it is a negative times a positive 5, so it's going to be negative 5 square roots of 7. Now, this last one, okay, here's why I like the box method. For this last one, you're going to take the square root of 7 times negative square roots of 7. First of all, a positive times a negative is what kind of answer? A negative. Secondly, we did this a lot last week. When I take the square root of 7 times the square root of 7, what do you get? You just get 7. Right? Because they're both under the radical. You could multiply those together and you get 49, but it's the square root of 49, which is 7. And it's a negative 7, because we talked about why that's negative. Now, here's what happens, and this is going to happen on a lot of these today. When we do the box method, we combine all these together for our answer. And usually with the box method with polynomials, you could combine that diagonal together. We're going to notice that the same thing happens on a lot of these. Notice how these are both square roots of 7. But I have 5 square roots of 7 and negative 5 square roots of 7. What's going to happen? We're going to cancel out. And here's the thing, if we would have been paying a little kind of closer attention, we may have been able to predict that was going to happen. Because if you look what I was multiplying 5 plus the square root of 7 and 5 minus the square root of 7. This is the same thing as when I did x plus 3 and x minus 3. Or x plus 5 and x minus 5. Or 2x plus 10 and 2x minus 10. When you have the same thing in both sets of parentheses, but the signs are different, the O and I cancel out. Those two boxes, when it starts out like this, are going to cancel out every single time, which is going to save us a little bit of work today. So the only thing I need to do is take 25 and negative 7, and I get 18. Now, this last one here, we need to be really careful with this last one. And the same thing happened when I multiplied something like x minus 3 quantity squared. I encouraged you, said it many, many, many times, but this is not x squared minus 9. Because remember, this is x minus 3 times x minus 3. In the same way, this is 6 minus the square root of 2 times 6 minus the square root of 2. So you still are going to do the box method, but you're just going to have the same thing on the top as you do down the side. 6 minus the square root of 2, 6 minus the square root of 2. Now the last one, we said that these boxes canceled out because they were the same thing, just different signs. That's not going to be the exact case here. They are going to be the same thing, but the same signs. Okay, so let's go through and fill this out. For this box, we would do 6 times 6, which is 36. This box here, maybe first figure out the sign. A positive 6, a negative square root of 2. A positive times a negative is a negative. The 6 is outside, the 2 is inside, so the 6 stays outside, the 2 stays inside. Notice for this box, I am also multiplying 6 times negative square root of 2. You're multiplying the exact same thing. This is also going to be negative 6 square roots of 2. And here's why I like the box method. Because this last box can sometimes be a little confusing, but you kind of have the room to show that. First of all, let's figure out the sign. A negative times a negative is a positive. The square root of 2 times the square root of 2, just 2, right? Just 2. Now notice the same pattern works out that on that diagonal, they're both square roots of 2. The last one, they cancel out because the signs were different. These aren't going to cancel out because they're both negative. This is where it comes into what we did yesterday. Okay? Negative 6 square roots of 2 and another negative 6 square roots of 2 gives me negative 12 square roots of 2. And then actually for these ones, I can actually combine that diagonal as well because it's just a 36 and a 2. 36 and 2 gives me 38. So I might squeeze that in the front there and get 38 minus 12 square roots of 2. Okay, let's get this glued into page 61. This is still section 10.3, and we are multiplying radical expressions. All right, so you're going to have, most of these are going to be a little more on the simple side. You'll have a couple that you have to think a little bit about. But the first few is just going to be working with the distributive property. So let's say we have the square root of 5 times the quantity, the square root of 2, plus the square root of 10. So the biggest thing you need to kind of keep in the back of your mind and remind yourselves of today is the big rules with radicals. You can multiply things on the outside together, you can multiply things on the inside together, but can't really mix and match here. So when you distribute that square root of 5, that 5 is inside, that 2 is inside. They're both in the same place. You can multiply them together, but they do have to stay under the radical. When you go and distribute the square root of 5 to the square root of 10, same thing. The 5 is inside, the 10 is inside. You can multiply them together, but they have to stay on the inside. Now remember, from yesterday, this is the square root of 10 and the square root of 50. Not like terms. They are not the same thing. But I may be able to simplify one or both of these. So if you start with the square root of 10, if you try to take 10, you divide out a 2 and a 5, and that'd be it. No pairs. So the square root of 10 stays the square root of 10. But when you take 50, you could divide out a 2, you get 25. Divide out a 5, and another 5. You can break down the square root of 50. You'd have a pair of 5s. So a 5 on the outside, and a 2 left over on the inside. So you do need to simplify them. Now, even when I simplify these, they're still not like radicals because this is the square root of 10 and this is the square root of 2. So you can't combine them together, but you would want to make sure it's in simplest form. Okay, number 2. 4 square roots of 2 times 4 minus 3 square roots of 12. Okay, just really take these piece by piece and take them slow. I'm going to take 4 square roots of 2 times 4. The 4s, they're both outside. You can multiply them together and keep them outside. You do still have that square root of 2. You just kind of tack it on the end. I can't multiply with anything else, so it's just going to get thrown on the end there. Then when I go to distribute that 4 square roots of 2 times negative 3 square roots of 12, multiply the numbers on the outside. 4 times negative 3 is negative 12. And then multiply the numbers on the inside. 2 times 12 gives me 24. And then remember, they're not like radicals. I can't combine them together as they are, but we do need to make sure they are in simplest form. 16 square roots of 2, there's not anything I'm going to be able to do with that because you can't take 2. You could, but you wouldn't get anywhere. But if I look at that 24, I can break down the square root of 24. If I divide out of 2, I get 12. Divide out of 2, I get 6. Divide out of 2, I get 3 and another 3, and we get 1. So, I have a pair of 2s, but remember the big thing I told you yesterday, there's already a negative 12 out there. So negative 12 times 2 is negative 24. And on the inside, I'm left with a 3 and a 2, so 3 times 2 gives me 6. They're both simplified completely, but not like radicals, because one is the square root of 2 and one is the square root of 6. So we can't combine those together. Yes?
Why do you, whenever you're multiplying 4 and 4,
right.
Why do you put the 2 with it?
So if you were, think back to like last week. If I had 4 square roots of 2 times 4, because that's what I'm doing, is I'm distributing and multiplying, right? Okay? So when you take 4 square root of 2 times 4, you could rearrange this because it's all multiplication. And you can move the 4 right in there and take 4 times 4 and just move the square root of 2 to the end. So the square root of 2 doesn't go away. There's just nothing else I can multiply it with. Does that help? Okay. All right, now let's move to some where we're going to do the box method. Let's say we have 2 square roots of 10 plus the square root of 3 quantity squared. Okay, now, so these are the ones where you're going to have to use the box method. Remember, these are the ones where it's tempting to just square both of these. You cannot do that. This is the box method where you have the same thing on the top of the box as you do down the side. It's going to be 2 square roots of 10 plus the square root of 3. And down the side, 2 square roots of 10 plus the square root of 3. Okay, here's why I love the box method. You can really take this piece by piece. So for this box, I like to take these, like I said, in pieces. I'm going to take 2 square roots of 10 times 2 square roots of 10. Multiply the numbers on the outside. So on the outside, I have 2 times 2, which is 4. And then multiply your radicals. Now, be careful here. I am multiplying the square root of 10 times the square root of 10. What is the square root of 10 times the square root of 10? The square root of 100, which is 10. So for that box, 2 times 2 is 4, but the square root of 10 times the square root of 10 just gives me 10. So you're actually taking 4 times 10, which is 40. That's why I like the box method, because you can kind of take it slow like that. This box, multiply the numbers on the outside. The only thing on the outside here is the 2. When you multiply your radicals, under the radical you have 10 times 3, which is 30. Now when this happens, I promise you, I guarantee you, when you have a quantity squared, these two boxes are going to be the exact same thing, because notice I'm also multiplying the square root of 3 times 2 square roots of 10, which is still going to give you 2 square roots of 30. Those two boxes are always going to be the same. And then for the last box, I'm taking the square root of 3 times the square root of 3. Anytime I multiply a square root by itself, remember what happens. What is the square root of 3 times the square root of 3? Just 3. Square root of 9, which is 3. Now for the box method, to get your answer, you're actually most of the time going to be able to combine both diagonals. Notice, that's just a 40 and a 3. You can take 40 plus 3, and you get 43. And notice on this diagonal, they're both square roots of 30. So you have 2 square roots of 30, and another 2 square roots of 30. You have 4 square roots of 30. And remember, when you're combining, which is what we're doing in that last step, the radical part does not change. Just like if this was 2x and 2x, it'd be 4x. This is still 4 square roots of 30. So let's try another box method, one number 4. 5 plus the square root of 6 times 5 minus the square root of 6. Now, one thing that can save you a little bit of work is if you recognize these patterns. So this pattern in this one, since it was a quantity squared, those two boxes are the same. Okay? For this one, this is the pattern where like I have x plus 3x minus 3, x plus 7x minus 7, x plus 5x minus 5. When that happens, the O and I cancel out every single time. Notice I have the same exact thing in both sets of parentheses, but you're adding in one to subtract in the other. What happens here is the O and the I promise you, 100% of the time, those two boxes are going to cancel out. So don't even give yourself a headache by even figuring them out, because they're going to cancel out every single time. you just are going to do 5 plus the square root of 6, 5 minus the square root of 6. You just have to do the first box and the last box. That's it. So this first box, 5 times 5, is 25. But the last box, first of all, it's a negative times a positive. That last box is always going to be negative. And then remember, just take it slow. The square root of 6 times the square root of 6 is negative 6. Yes, very good. So your answer, 25 minus 6, is just 19. Okay, let's try just a couple more. Okay, number 5. Let's do 3 square roots of 5 minus 2 square roots of 3 quantity squared. Okay, recognizing the patterns here. When you have a quantity squared, I promise you 100% of the time if it's a quantity squared, those two boxes are going to be the same. They're going to be the exact same term. So when you take 3 square roots of 5 minus 2 square roots of 3, and on down the side, 3 square roots of 5 minus 2 square roots of 3, I promise you those two boxes will be the same. Now let's take this slow for this first box. Multiply the numbers on the outside. 3 times 3 is a 9 on the outside. When you multiply your radicals, the square root of 5 times the square root of 5 gives me 5. And 9 times 5 gives me 45. Now, these two boxes do the same thing. Multiply the numbers on the outside. 3 times negative 2 is negative 6 on the outside. And then multiply your radicals. The square root of 5 times the square root of 3. 5 times 3 will give you the square root of 15. 100% of the time when you have a quantity squared, this box is going to be the exact same thing. Also negative 6 square root of 15. And then my last box. Multiply your numbers on the outside. Negative 2 times negative 2 is a positive 4 on the outside. And then multiply your radicals. The square root of 3 times the square root of 3 is just 3. 4 times 3 gives me 12. So I can combine this diagonal, 45 plus 12, gives me 57. And I can combine this diagonal because they're both square roots of 15. So negative 6 square roots of 15 and another negative 6 square roots of 15 would give me negative 12 square roots of 15. And remember, when you're combining, that radical doesn't change. Okay, last problem here. Okay, number 6. Let's say we have the square root of 5 minus the square root of 3 times the square root of 2 minus 3. Now I want to pay attention to these patterns. We have the quantity squared, which isn't a quantity squared. And then we had that one where you're adding one, subtracting the other, but they're the exact same thing, where that diagonal cancels out. That's not this one either. So there's no patterns here. You're just going to do the straight up box method. No patterns, no shortcuts here. We're going to do the square root of 5 minus the square root of 3, the square root of 2 minus 3. For the first box, the square root of 2 times the square root of 5, they're both under the radical. 2 times 5 gives me the square root of 10. This box, first of all, figure out the sign. A positive times a negative is a negative. And then the square root of 2 times the square root of 3 both under the radical, we get the square root of 6. In this box, once again, figure out the sign first. A negative times a positive is a negative. But this time, the 3 is outside, the 5 is inside. 3 has to stay outside, 5 has to stay inside. This one right here, a negative times a negative is a positive. But this 3 is outside, that 3 is inside. So that 3 has to stay outside, that 3 has to stay inside. Now looking at this, I'm trying to combine all these together if I can. Are any of these like radicals? No, so knowing what we know from yesterday, I should probably try to check and make sure they're all in simplest form, but spoiler alert here, if you tried to take all of these, none of them would break down. Which means I can't combine any of these together. Which just means your answer is the square root of 10 minus the square root of 6 minus 3 square roots of 5 plus 3 square roots of 3. 4 separate terms that you can't